Good morning to all of you. I'm happy to welcome all of you for the today's webinar on structural monitoring of bridges, case study and significance of monitoring temperature and humidity by Dr. Professor Chandramouli SC, Department of Civil Engineering, PES University, Bangalore. I'm very happy and honored to welcome today's speaker for the webinar proposed by structural health monitoring. It is a need of the hour. We have to know about, and also I'm happy to share that the many delegates are registered for this webinar, and also many students also shown very much interest. I welcome all the webinar delegates and the students. I welcome these all the delegates on behalf of management of NCET and Department of Civil Engineering and my own behalf. Happy morning to all of you. And also I will thank Professor Chandramouli SV for readily agreed to deliver a talk on structural monitoring of bridges. My association with him is almost 4 to 5 years. He has already delivered 3-4 lectures. So last webinar also during COVID period, he has delivered structural monitoring of buildings and also the landslide analysis. The third series of lecture he is giving us for the benefit of all of us. And now I request the coordinator of the program, Mr. Sanat Kumar, to introduce the speaker of the today's webinar. Mr. Sanat Kumar.
Yes, sir. Good morning, one and all. I welcome our HOD, principal, management for giving this opportunity, and I welcome them for this function. I welcome all the faculty participants from the various colleges and student participants. Today, I take this opportunity to introduce our speaker to the audience. One second.
Please go ahead. We are audible.
Yes, yes, sir. Yes, sir. Dr. Chandramouli is presently working as a professor in the Department of Civil Engineering, PES University in Bangalore. Chandramouli has been honored Best Professor in Civil Engineering Studies at the 27th Devang Mehta Business School Award in 2019. He accomplished professional engineering with more than 18 plus years of industrial experience and key member in national and international projects of esteemed organization, provided technical support and expertise to the project in Australia, Finland, Vietnam, Russia, Turkey, Japan, China, and Brazil. Previously, he is worked as an independent structural and SHM consultant in Bangalore during the period additional to the consultancy project, worked visiting faculty for various engineering colleges. He worked as a SHM in Finland. Next, he worked as a development scientist and manager SHM with Sevkur India, responsible for advanced rehabilitation technology and SHM business. He has almost published international journals and international conferences. He has attended 12 and national conferences 18, journals 12, 2 magazines, article 8, invited talks 20 plus. And he is one of the renowned speaker, and he got his doctoral degree in the year I just confused the line. Thank you. He is a well-known speaker, and I request him to deliver a talk on the structural monitoring of bridges, a case study on significance of monitoring temperature and humidity. I welcome you, sir, on behalf of the college management and the department. I welcome you for this webinar, sir. Please take over, sir.
Good morning, dear all, and to my dear teachers, colleagues, friends, and one and all present here. I thank the organization and the organizing institute, Nagarjuna College of Engineering and Technology, for inviting me as a speaker for this webinar. On behalf of my department, the PS University, I wish hosting institute and the Department of Civil Engineering of Nagarjuna College of Engineering a grand success in all their efforts. I must personally thank Professor Venkatesh Babu, who is the HOD of Department of Civil Engineering, for his personal invitation. And the professor has been consistently motivating, inspiring people and his team for the development of his department wherever he has been. I've been known him since almost since 4 years or 5 years maybe. But I've been looking at him and getting inspired because wherever he is, he puts his 100%, and he's been a good inspiration for his team. So I firstly would like to wish him a good luck for all his efforts that he's putting in to make his department and the team surrounding him and his colleagues and friends always being inspiring and making it a grand success.
Thank you, Professor, for your nice words.
The pleasure is always mine, sir. Thank you. So I had to admit a lot of people because I'm also trying to host it. So kindly excuse me if in case I take a few minutes or a few seconds of break in between, so that I need to admit people who are just waiting. Yeah.
Yes, sir, please.
Now, thank you, Professor Sanath, for the kind words and the introducing me in a short while of period. I think you were able to gather my biodata the previous night at 2 a.m. I was a little astonished because although I was quite busy with other activities, and since it's a COVID situation, you know, everybody are in the panic mode in all the because of their own situations. I've also undergone a lot of ups and downs, and there has been a lot of bad days also. So definitely there will be the time is always precious, and we are all here to share the best experience what we have got. So I should be thanking Professor Sanath for his kind words of introducing, and I'm presently working as a professor at PS University. Over the 2 decades of my experience, I've been responsible for the structural health monitoring business and structural remedial engineering, as well as structural designs. I wish that we could have all met in person and shared knowledge offline. Nevertheless, I'm very much pleased to be here on this online platform to share this knowledge through this webinar. The topic of my presentation is structural health monitoring of bridges. Specifically case study on significance of monitoring temperature humidity, which is a present day, everybody is aware of, the temperature monitoring. I thought this would be the right situation for me to also explain on the structural health monitoring and the significance of monitoring the temperature humidity. Yeah, few more to admit, yes. Before I start my presentation, as usual, I acknowledge to all my teachers for their contributions for what am I today. I strongly believe that if you put your 100%, things will fall in place. And the very famous proverb says that when the student is ready, the guru will appear. And when your efforts are to the 100%, the success is sure to be there. And I should especially acknowledge my teachers from UECE, specifically Professor N. Maruyudrappa, Professor V. Jagannath, and Professor Devraj, who've been helping me since the day when I was in the college, during the days when I was in very bad shape. And these are the people who inspired me, or who have been constantly in touch with me. And today I believe both the professors, or all the professors are on this webinar. I welcome you all, professors, and I thank you all to inspire me and help me what I'm today. Before I start my presentation, I would like to introduce to few of the projects that I was involved in. And this would help the participants to seek clarification if they need, not just limited to this particular presentations. So The few of the projects that I've listed are the structural monitoring of Raw Bridge in Haiphong, Vietnam, the online monitoring system for the Golden Horn Bay Bridge crossing, Russia, health monitoring of Neva Cable Stay Bridge, St. Petersburg, the new Marinsky Theater in St. Petersburg, the Crusail Bridge in Finland, and a few projects in India are the load and periodic monitoring of road or bridge, or OB161 in India, in Baramulla, Jammu and Kashmir, and structural monitoring of a steel truss bridge that is 120 meters span at Bangalore, Karnataka. The load testing of the viaducts of the metro projects to evaluate the dynamic augmentation coefficients. Various other vibration monitoring at various in the various industrial areas, Kolar, Bellary, and various other places in Karnataka. The few of the measurements in abroad on human comforts. Then few research studies that has been conducted at various universities. Have been also a consultant for those academic works on the free and the forced vibration of various specimens, and a few projects on estimation of dynamic properties of soil and the vibration related to soil and geodynamics. The measurements of monitoring of street pool, it's a big business across the globe. Someday, maybe if there is one more opportunity, I will talk on this. And vibration monitoring on the effect of flow vibration due to moving vehicles on sensitive equipments in the neighboring country. So these were a few of the projects which I could list, and if in case if there is any clarifications or any suggestions that is required from the participants, I would be happy to share, not just limited to this presentation, but those projects also. So today's presentation is going to be on the structural monitoring of a bridge, and specifically on the case study of significance of monitoring temperature and humidity. See, the outline is going to be the introduction, structural health monitoring, benefits of structural health monitoring, and case study on the significance of monitoring temperature and humidity, and some few closing comment. Although the outline looks very simple, and my presentation is going to go at least a long of 2 hours. Hope your hosting organization and the department organizers would accept such a long presentation. If in case any point of time, if they require for me to, end, kindly let me know. I will definitely wind it up at the earliest. Now, as we all know, the civil industry is an evergreen and ever growing. We basically build what we call the living companions to all. Now, during this COVID situation, you would have understood that the only thing that is going to be ever, forever immortal is our civil industry, because your building is going to stand, but humans are always mortal. Civil infrastructure and construction technology have been evolved over centuries, as we all know. And as you all know, on the present day, it's at the most faster rate it's been growing. And as you all know, the civil infrastructure is expected to hold the largest market share in the next coming decade after this closed down. Now, it was projected that the India would become the world's third largest construction market by 2025. Because of the pandemic, I think it will be still there, but the days or the number of years it will take to be extended. So therefore, the infrastructure sector is the key driver for the Indian economy or any other economy. Civil infrastructure facilities, as we all know, can include numerous critical structures, such as the bridges, dams, tunnels, highways, and buildings. Now, in the construction industry, presently we're in the state wherein, because of the rapid urbanization, there is a need for the new construction, and there is a need for retrofitting the existing structures. Basically, we are either to construct new ones, or we need to take care of the aging infrastructure. Now, as we all know, we've been professors, we've been explaining students on most of the modern complex designs, and then the structure being so complicated with a lot of materials inbuilt. So as we all know, the present structure, the recent development in the technology has enabled the modern construction of structures that consist of most complex design, such as the complex geometry and conditions, incorporating complex systems such as the control devices, the composites, built with advanced. Okay. So built with advanced material quality and supported with sophisticated analysis, design, and rapid construction. And all these modern constructions or modern infrastructures are subjected to aging, and also is also subjected to traffic volume. Uh, I think
You can mute him. Yeah, okay, he has muted.
yeah. Okay.
There is an audio little bit low, it seems. Please check your audio.
Is it? Okay,
Yeah.
fine. Let me check on that.
Yes, sir.
Is it fine now? Is it fine?
Now it is okay.
Yeah, fine. So we've been able to construct the tallest buildings on the large span bridges. So almost we are reaching to almost to 2-3 kilometers span of the bridge. Now, as you all know, the globe is getting hotter day by day, and the temperature is rising. This is attributed to global warming and climatic change. This is being the present day talk. Now, it is necessary for us to know the term weather and climate, and these are quite different. Weather events are defined as a state of the atmosphere in the particular location at a particular time, whereas the climatic change includes major variation in temperature, precipitations, wind patterns, and other environmental conditions that would occur over several decades or longer. It takes more time. So that's the climatic change. Now, the climatic change is the cause, the climatic change is the cause for the structures to be affected, and the climate is changing because of the global warming. The change in the climate and the weather are linked over the long term, but no single weather event, such as what we had recently, the tornadoes or the cyclone, can specifically be attributed to the changing climate. So that means the one single weather cannot dictate the climate, basically. It takes a long time. Now, so most of you are aware of the greenhouse effect. So there are two definitions for it. So that is, one is the natural greenhouse effect, okay, and the human enhanced greenhouse effect. Now, as you all know, the increased concentration of greenhouse gases in our atmosphere results in less heat escaping into the space and more being absorbed by the atmosphere, hence warming the temperature of the earth, that is global warming. This is known as the enhanced greenhouse effect. Though the slide will give you a complete picture, on the left hand side is going to be the natural greenhouse effect. The right hand side is the human enhanced greenhouse effect, and because of the various greenhouse gases. Okay, so the increase in the greenhouse gases. So there is less of heat that escapes into the space. Thereby, we have more of global warming. Now, if you all know the Arrhenius, he's basically is the scientist. In 1896, he first speculated that the change in the levels of carbon dioxide in the atmosphere could substantially alter the surface temperature through the greenhouse effect. And he also warned that if burning coal would double the concentration of carbon dioxide in the atmosphere, and the temperature of the earth could rise by several degrees. And that was the definition of enhanced greenhouse effect. That was the day when we got to know that the definition of enhanced greenhouse effect. So if you can see, the sunlight passes through the atmosphere and warms the earth. The second is the infrared radiations is given off by the earth. And the third is most of those escapes to the outer space, allowing the earth to cool. But some infrared radiation is trapped by the gas in the air, that is the carbon dioxide, keeping the earth warmer enough to sustain life. Now, therefore, the increasing of the carbon dioxide increases the amount of heat retained, causing the atmosphere and the earth's surface to heat up. So this is all about the greenhouse effect and the enhanced greenhouse effect. So thereby, we have a problem on the climatic change because of the global warming. Now, as you all know, every sector or industry or organization is contributing to the greenhouse effect. Now, according to the WHO, who's been in the limelight in the last few years, people every doorstep or every person, individual in the globe knows now who is WHO. So according to the WHO, a carbon footprint is the measure of the impact that any activity, that is either by the sector, industry, or the organization, have on the amount of carbon dioxide produced through the burning of any of the fuels, and is expressed as the weight of carbon dioxide emission produced in tons. So basically, the sector that is contributing to the greenhouse effect can be measured by its carbon footprint, and that is measured, because of its carbon dioxide emission produced. Now, the carbon footprint is a very important means to understand the impact of the person or the organization or the sector's behavior on global warming. So it is every individual's concern to take care and to minimize the this particular global warming by taking care of the emission of the carbon dioxide. Now, because of this, because of the carbon footprint and because of the contribution or the increase in the carbon dioxide, we've been seeing the constant trend in the increase in the temperature since 1900. If you see this graph, this has been taken up from the Berkeley Earth organization. So you can see that the temperature has been constantly increasing over the period of time, and this is a trend in India. Now, if you take the whole of the globe, now you can see that the variation in the Earth's average surface temperature over the past 200 years, you can see that on the x-axis you have the number of years, and the y-axis you have the temperature, and you can see how the temperature is varying, and the average temperature is taken as 15 degrees centigrade. That's zero line. So you can see that how the temperature has been increased after 1940. It's been constantly increasing. And the global temperature record since the instrumentation began in 1860 and the projection up to 2100, this is according to IPCC. You can see that how the climate is going to be, how the temperature is going to rise. So there, as you all know, there is no happy news for when it comes to the temperature. Now, this is in context to my presentation, so therefore this basic understanding of things is important, because we are into structural health monitoring. In health monitoring, or the monitoring is not just to find out how much of changes have happened, but we also have to get into the action mode, wherein you diagnose the problem and then you need to suggest something. So basically, understanding why the problem started is very much prime important. So therefore, because of the greenhouse effect, that is because of the enhanced greenhouse effect, because of the carbon increase and the carbon footprints by each and every the sectors, we have the rise in the global temperature, and thereby you have the various effects. So what is happening on the global scale is that the temperature is increasing. Now, as you all know, the carbon dioxide is also increasing, which is also a major pollutant, and there is also the increase in acidity in the oxygen, that is the ocean water. Now, how does it change the climate effect on a particular region? As you can see from this slide, there's an infographic which explains that increase in heat, less snow, less snow and rising sea level, the public health, then heavy rain events are increasing, as you all know, and most frequent coastal flooding, increased wildlife, so extreme river conditions, increased cost. So these are the effects that because of this climatic change. So what would be our future? So as you all know, because of this change, there'll be lots of effect on various sectors and various surroundings surrounding us. So there'll be a lot of flooding, and there's going to be low snowfalls and record temperatures. The fire can increase, landslides risk, poor air quality, and a lot of food and illness. So airborne diseases and other things would increase. As you all know, we are in the present day COVID situation, even that is presently being declared as airborne. Now, this is going to affect various, it is going to affect yeah. Now it's going to affect the region, and there is going to be a risk for the various sectors, that is environment, economy, and health sector also. There is going to be a huge increase, or the huge risk that is going to be involved in the cost, and this would be ever growing. Now we all know that we have the evidence because of the temperature. There's going to be a severe drought because of water and temperature. We have extreme precipitation events in the coastal flooding. And we all know because of the temperature, there's going to be heat wave. And we have the strongest evidence because of the scientific finding. And there is a little evidence on the water plus temperature causing the tornadoes and hurricanes, which has been extensively studied in these days. Now, most of you would know the definition of a structure. So we can take any structure, but not necessary to be a civil infrastructure. It could be a mechanical or aerospace structure. All are affected by the temperature. Now, as you know, the best example to understand the structural temperature, because as I further proceed, I would try to admit few of the participants and then mute them all and then get back. So as you all know, the best example to understand the temperature or the surrounding temperature and the structural temperature, the best example is when you park your car in the open sunlight, okay? So as you know, the temperature surrounding would be 80 degrees or 80 degrees Fahrenheit, that would be about 26 degrees centigrade. And the increase within the car is going to be about 50 degrees centigrade, that is 123 degrees Fahrenheit. Now, as you all know, you park for the time of increase is, the increase of temperature is going to increase with time. So therefore, the time is also a major factor, and the rate of increase depends on the material or the surface that is exposed. Okay, so that's very, very important. Now, as you all know, today we are in the situation wherein the temperature is quite high, and there are a few things that was floating in the social media on the cars getting melted in few countries. The various various components of the car are being melted, and if you take a fact check on that, it is just the damage that was caused close to the construction site, which was subjected to some fire, or there was a fire in some construction site, and that led to this. But still, for a civil engineering point of view, you know that whenever there is a fire in the adjacent building, it's going to affect the building that next to it. So definitely, although the news is fake, but this is a eye opener to the civil engineers or the structural engineers. So when a neighboring person is infected, definitely you're going to be infected. That doesn't mean it was just a gossip or something, but you need to keep yourself safe and in check. So as you all know, because of various phenomena, that is the enhanced temperature or the harsh environment, and because of the aging factor, these two factors, the infrastructures are deteriorating. And this is not just a problem only specific to one particular nation, but it is also it is a problem across the globe. So I had to mute every time because of to admit people. Can you excuse me if I take a short break because I need to admit and mute few people. So as you all know, structures are designed to sustain loads as per the standard code of practice, and is also subject to aging and harsh conditions. Now, during its service life, as you all know, the harsh condition could be the wear and tear, the chemical attacks, the corrosion, and various other factors, including the high temperatures, fire, and other things. And we also know that the aging is definitely a slow process that also deteriorates the structural capacity. Now, the loads clearly show a tendency to increase over the lifetime of the structure. However, if the applied load increases continuously, the deterioration would occur faster. So if in case we have the load that is being increased in accelerated way, the deterioration is also going to be accelerated, or the deterioration is going to get faster. So as you all know, the load is never constant, the capacity is never constant, because the capacity decreases with age and also on the rate of loading, and it is always changing. But whereas the load is always variable, it's totally uncertain. So whenever there is variability and uncertainty, these parameters of uncertainty or variations can be best represented by the probability distribution. So the probability distribution curve, if you take at any point, as the time progress, the demand exceeds the capacity, and it is evident that the time varying probability of failure increases. So as we all know, the design must guarantee the performance, that is the functionality and the strength and durability that is dependent on time. And structure in general are intended to perform safely during its design period. When it enters its service, it is close to perfect or is in agreement with the engineering expectation of the day. Over the time, the structure loses part of its initial capacity. As you can see, there is going to be a cumulative damage over a period of time. Now, when the structure is found to reach a limit of acceptable minimum performance, that could be determined by the routine inspection, what is being done by the structural managing team, it has to undergo the repair to recover its initial capacity. If it is at this point, if it is neglected, basically the structure would be decommissioned, or it would won't be performing well. Now, as you all know, every structure once in a lifetime should be subjected to some type of extreme event, such as an earthquake or any other type of extreme events. And after an extreme event, it is being again inspected and it is retrofitted, and the same cycle would repeat. That means after the retrofitting, there will be accumulative damage, or there is a deterioration of damage. As you can see, there is numerous uncertainty that is involved in every phase. So what is that uncertainty? The X and the Y parameters. If you look at the X and Y parameters, you are not definite at what time the rate of deterioration would lead to the decommission of this particular structure. On the Y-axis, what we have the performance, we are not aware up to what point it will perform after it is being designed. And the rate at which it falls is also uncertain. There is total uncertainty. So in order to extract knowledge on understanding, or in order to understand how this deterioration takes place, there is a need for the information. So this information is basically obtained from those data that are collected from these structures. In the present day, there is a reactive based maintenance, which is still a reality. The preventive or the time based or condition based still not being practiced. Yeah, I mean, in few cases it has been practiced, but it is not completely practiced. The the predictive or the forecasting based is still the need of the hour. So the all this predictive or the forecasting based or condition based is dependent on the data that is acquired and the information that is obtained in context with that particular situation. Now therefore there is total uncertainty. Now, as you all see, this is basically the figure shows the weather probability distribution, which is the extreme weather or the weather conditions that you can see that is going to happen, that is being changing. So the weather probability distribution showing an increase in the mean temperature. Now, the figure demonstrates the shift in the temperature towards more hot weather. As you can see, it's moving towards hotter weather, and slightly decrease in the cold weather, as you can see in the left of the slide. The climatic change could mean that what was historically a rare weather event or a rare event becomes increasingly frequent. That is because of the possible shifting from the rare to occasion or the regular. The consideration of how we respond effectively or not to an extremely rare event occurring today can provide useful information on how we can or how we should respond to the increasing future risk. So optimizing for the today's extreme weather event makes our system more prepared for the increased frequency of some events that is anticipated under the changing climate. So as I said, the structure is deteriorating because of its aging and because of various factors, what we saw earlier in the previous slide, and as well as the load is ever changing. And there is a shift because of the shift, and there is a drastic climatic change. So therefore, the structure that was behaving previously is completely different, and because of the shift. So therefore, understanding the present day would help us to know the performance of the structure in the future. Now, in most of the experiments, certain quantities are measured and the other quantities are determined from the measured data. Always associated with each measured quantity is the measured uncertainty. When a final result is determined from the measured quantities, these measured or the measurement uncertainties leads to uncertainty in the derived result. So whatever we have derived, because of the uncertainty involved in the measurement itself, could be also uncertain. The procedure by which an experimenter determines the uncertainty is the final result from the measured uncertainty and is called as error analysis or propagation of uncertainty. As we can see from the slide, the uncertainty over a period of time increases if it is measured over a long period, or the uncertainty what is today would be completely extremely going to be increased because of the time or over a period of time. So when you know these factors, so as you know, this is a complex situation in civil engineering. So although we learn from the books, it's quite simple. So I would like to invite, just admit few people who are waiting. Yeah, in general, the civil infrastructures are subjected to aging, increasing demand, aggressive environment, and other factors. And this is also this is leading to the damage or the deterioration or the change in performance. And if there is an inadequate performance assessment, or when we have no proper protocols for inspecting, when you have an inadequate performance assessment, there is a decreasing capacity and there is an increasing risk of failure, and thereby consequently the failure of a system. Now we have to understand what is the failure of system, because I said if in case it is having a low uncertainty or taken care of every of the factor, the failure of system could mean the optimal performance of a system. If in case the uncertainty are not accepted or is not considered, or there are various factors that is affecting the structures and there's an inadequate performance assessment and there's a huge risk of failure, we say the system can also collapse, or there could be extreme failure of the system. So the failure of system, its definition itself is quite it depends on that particular situation. Now, as you all know, for any engineering problem, obtaining the reliable data is always the first and the fundamental step towards finding a solution. Now, what we need is more information, and more informations. With informations, we get knowledge to understand the failure. And the failures that is already there, or the failures that we have understood over a period of time, and their analysis will also lead to the new insight and also help us to improve designs of the future structure. Now, monitoring structures, which is the present day talk of mine, using the sensor technology is one way of getting the quantitative data about the structure and the other parameters that encompasses the uncertainty, and help us to take the informed decisions about the health and the destiny of the particular structure. Now, as I said, that structural health monitoring is an emerging vital tool to help engineers to improve the safety and the maintenance of the critical infrastructure. The objective is to lower the maintenance cost and increasing the reliability of the structure. And basically, it's presently been accepted by the majority of civil engineers fraternity as a potential method of assessing the condition of the structure. Now, the development of structural monitoring technology is basically for surveillance, evaluation, and assessment of existing and newly built structure that has been, and it presently has been now attained to some maturity. That means extensive research has been conducted and it is being implemented on site. And presently, people have been using, because of the because of the low cost IoT technology that is being adopted in structural health monitoring. Now, for those people who are very new to the subject, it's basically the analogy is going to be the process of acquiring and analyzing data from the onboard variety of sensors and measuring technique to determine the health of a system. It could be as simple as that you're monitoring the health of an individual. Similarly, you are going to monitor the health of your civil infrastructure. Nowadays, everybody is aware of what is meant by monitoring, because we've been constantly monitoring people, and the media is helping us monitor. Even if you're in a very bad state or in a good state, you try to monitor so that you are always in the positive state of mind. Now, as you all know, the parallelism between the medical activity and SHM is going to be there are different phases of life. The birth monitoring, and you have a birth. During the birth, you go for the monitoring, and that's called a process monitoring. Health checkup, regular routine health checkup, whether you are in sound health or not. And the same type of monitoring can be done. And when you're in a deep illness or close to the death, there is something called clinical monitoring, and there is a damage monitoring when it comes to the structure. So that's the parallelism that could be understood from the medical activity and the SHM. Now, the benefits of SHM are various. You can look into various literatures that gives you the benefits, but I've tried to just to bring a few of those so that those people who are very new to SHM, they could understand. I've made my presentation in such a way that all are benefited, from the students to those people who are in the advanced levels of understanding monitoring. So monitoring reduces uncertainty because it takes care of various parameters that has been monitored. You can also discover hidden structural reserves that you are not taken care in the designs. Discover deficiencies with time and increasing, and also the increasing safety. This can help to buy some time, as well as increase the safety. Monitor, ensure long-term quality. You can also monitor the quality of the structure, allow structural management. So these are limited things that I try to put it across. And as well as this monitoring increased knowledge, because you created a strong database for others to work on those and develop their models, and as well as share those models to the academics and then get into the practicalities and then go get into the code of books. So code of practices. So therefore, there are various benefits of monitoring in context to what you're being monitoring. And as you all know, this the benefits can be easily looked into when you're reading some articles. Now, the definition of it, the structural health monitoring or the structural monitoring is the technological driven automated solution whereby sensing devices are installed and which will remain in place or in or on a structure with the intention of capturing the structural data on a continuous basis over a period of time for the purpose of objectively and accurately assessing the structural performance. So that's the definition of it. So we are using some sensing devices that are installed and being constantly monitored. Basically, the structural health monitoring is the combination of It's basically called Civonics. It's a combination of structural engineering, the civil engineering with electronics. It includes structural engineering and data science. And as you all know, the Civonics is a new term that was coined in 2003, and it is applicable to application of electronics in civil engineering. Now, the monitoring, the structural health monitoring can be applied for usage monitoring or operation loading to collect operation loading data, health monitoring, and if there is any presence or quantity variations or the performance variation. It could be also maintenance monitoring. It could be reactive monitoring, corrective monitoring, prevention monitoring, or predictive monitoring. So basically, all these words, whenever you have a situation, you have a maintenance program, you would call for the structural health monitoring. Now, the present day, most of the engineers are aware of the word structure and they know the definition of structure, but the health, the word health within the structural health, or the definition of structural health monitoring has got different meanings based on that particular situation. So it has different meanings and connotations. So therefore, the present day, the most of the practitioners have stopped using the word health, and they try to avoid the word health in structural health monitoring, and they just define it as structural monitoring. And I would be using both, and both means the same. So if I use structural health monitoring or structural monitoring, it's one of the same. But the present day, the practitioners would not use health because of various reasons. And if somebody has got some questions on it, I definitely try to answer those. Now, the application of structural monitoring to civil infrastructure does not rule out the routine things that is being presently practiced in the industry. That is the visual inspection, non-destructive testing and evaluation, and short-term monitoring. There are various terminologies that is presently being noted by various industries and extensively used by people around, but all means the same, and it has got its own specific objectives. And the terminologies are the non-destructive evaluation, structural monitoring or measurements, structural health monitoring, condition monitoring, and damage prognosis. Now, each monitoring project has its own peculiarities, and although it is possible to standardize most elements of the structural monitoring system, each application is unique in its own way, and they are combined. So the classification of monitoring is basically a combination of various things. Now, here you can see on the slide, you have the time schedule. That is, you monitor periodically, continuously, and the sampling can be taken low speed, high speed, event driven. The objective that is being monitored, the phenomena, what you're going to monitor, the instrument, what type of instrument you use, and what type of response you're monitoring. So you can, since every project is unique and peculiar, so what you do is try to combine and make it a topic. Like, let's say you want, in the present day topic, highlight it as structural health monitoring of structures and the significance of monitoring the temperature, humidity. Therefore, that doesn't mean that I'm an expert in the various other fields. It doesn't mean that I am also aware of other things. So basically, this particular field is quite it has its own wings, and the few people who have worked on for certain projects could only talk on those projects and would be expert in that project. But it is quite a complex, subject, and vast subject basically. So whenever you get involved in a particular project, you try to know much on this, and basically it gives you a basic idea of the other monitoring schemes. Now, the mission of the structural monitoring is to provide as much as information as possible in the most simplest and most complete form to be used by those who are to make a decision. And basically, who are going to make the decision are basically the people around, or the people who are into the management or the government. So basically, they require the information in the most simplest fashion. So as you all know, there is this COVID situation wherein, you wanted to monitor the beds, and presently, there are few politicians who are making their efforts to provide those beds online and get to know what is really happening in real time. So the similar kind. So you're collecting the data and you have to provide it in the most simplest fashion. That's most important. And you need to give the most complete way. It has to be complete, and it has to be that can be used. Okay, this is very much important. And you should also know the information is always in context in which the data is taken. So you need to, information is also the result of processing the data gathered. So that means information depends on processing, gathering, manipulating, and also organizing the data. Therefore, you have a mission to provide the data in the most simplest and most complete form to be used by those to make the decisions. But here is a scenario. Now, you also know, because of the, if somebody is critically ill and you have the technology that is also there, you can see that there is a technology, the sensors that is being put on this particular patient, and you can see there are monitoring schemes that is there, and there is a expert or the subordinate to an expert who is also trying to see what is happening. So, and there are people who are panicked. So basically what we require is the information. So now presently the data are passing and it is being collected. There is a lot of data that needs to be interpreted. So you can see here, the interpretation depends on the expert. And look at the situation of the people who are dependent on that particular expert. So therefore, now what we need is not just basically information, but we need the reliable information from the reliable source. So, and you need to also have the reliable system in place and expertise. So I think that would help you to understand the seriousness of structural health monitoring. And it is not just to provide the information, but to provide the reliable information as much as possible in the most simplest and most complete form to be used by those who are making the decisions. Now, as seen from the previous slide, to see the health monitoring of a critical patient, the decision making may arise similarly in structural health monitoring or structural monitoring of civil infrastructures. And for that, the essential features of structural monitoring scheme or the structural monitoring technology or structural monitoring devices includes the reliable and economical instrumentation. That's prime important, because economy is the first most important thing that lets you on the wide implementation of the instrumentation. Accurate signal processing, expertise with the knowledge and skill in the information process. And the success and the effectiveness of each of the tool for the project depends on the availability of reliable data. So although you have things in place, everything in place, still we need the reliable data. That's also plays an important role. So on the whole, you need to have the best things in place, and not just knowledge, but you should also have the skill sets. Now, the components of the structural monitoring scheme, I would try to go fast because these are the basic things. So from henceforth, I'll be a little fast. I'm getting back to my case study and I'll go slow over there. So now, as you can see, the modern structural health monitoring system will typically consist of 6 common components. That is presently the structure or the system that needs to be monitored, the sensors that are placed onto the system, that are placed onto the system, the data acquisition systems that acquires the data from the sensor, the data transfer and the storage, the data management, data analysis, and diagnostics. Okay, these are the major components. From these components, we try to find, diagnose, and analyze, and then we try to use those data to successfully provide the solution to the civil infrastructure. And as you all know, the monitoring scheme is basically it's a networked, well collaborated, multidisciplinary activity And the monitoring system, as you all know, is multidisciplinary system integration approach. So wherein you have various components and various hardwares from various discipline fields that are integrated and combines to form one particular reliable system. So the monitoring system, the successful monitoring system, or the success of the application of the monitoring scheme or the monitoring technology depends on how well we have been collaborating with various departments. Now, as you can see, there are various disciplines, not just civil engineers. It's also sensing technology, communication, storage, the signal processing, health evaluation, and power technology, the electronics, electricals, the computer science, the information science. All those people have to be collaborated, and they come up with a system that is going to be reliable. And as you can see, the advancement in each and every field is going to be rapidly changing, and they need to be aware of this particular technology that is being implemented into civil engineering. And once there is a collaborative efforts from all these sectors, then only you would see a progress in the monitoring system or the development of more reliable monitoring systems to come in place. Now, the first component is the structure. Most of the questions that will be asked is which of the structures can be monitored. As I told, I mean, has been presenting in various conferences. I've been told to define few of the basic things. So I try to include this. So practically, we can monitor any of the structures, be it new, old, micro, macro, or to any scale. It could be on Earth or in space. So we can monitor any structure. It could be a single structure, it could be a complex set of structures, it could be the whole city, or it could be anything. So basically, it could be a temporary structure or a permanent structure. So practically any structure can be monitored. At what stage we need to monitor? As in case of the health monitoring, we can monitor at the happy stages, and when you're really worried, so you go for the diagnostics. And sometimes when you're critically ill or you're in the very bad state, you go for monitoring. Therefore, the same analogy, you can monitor the structures at any stage, beginning from the design stage, the model testing stage, construction stage, the commissioning stage, in-service stage, maintenance stage, retrofitting stage, before and after retrofit, whether the retrofit is effective or ineffective, the mobilization stage, when you mobilize one structure to one place to another place, or you lift the structures from one level to other level. You need to monitor every component of it if there is any stresses that is being induced. So therefore, you monitor before and after it's been mobilized. Demolition, whenever you go for a demolition, you need to see that whether the environment is affected, the surrounding environment is affected, whether the structures surrounding it is affected. Therefore, you need to monitor before and after the demolition. So basically, in the life cycle of a civil infrastructure, you try to admit few people. Yes. So basically, you try to monitor the civil infrastructure at various stages. So you can see that there is a commission stage, inspection stage, damage stage, and retrofitting stage. This is a whole service life. In the whole service life between construction to renewal, you have various inspection that can be done, various structural monitoring scheme that can be provided, or various type of services that is being provided. And it can also monitor the every stage, and that's called as the continuous online monitoring scheme. So basically, the structure that is that it needs to be monitored can be monitored in various phases. It can be monitored at a definite point, at after a situation, and it could be monitored continuously. So, and it could monitor only a specific parameter, or it could monitor various parameters at once. Now, which of the components or the section of the structure need to be measured? So the answer to that is you can measure the whole structure, or you can also measure one of its component of a structure. So basically, it's called as a global monitoring. When you're measuring the whole, you're considering the whole structure in your analysis, and you consider a portion of a structure and then monitor because of its local behavior. To understand its local behavior, it's called as a local monitoring. The second thing is the sensors. Now, what is a sensor, or what are the types of sensors that is available? So the electronic students are very much aware of it, and nowadays every individual is aware that about the sensors, because you're using smartphones. Smartphones have got various sensors, and therefore everybody is aware of it. So it's a device for sensing a physical variable of a physical system or an environment. That's a book definition of it. And the sensors are there to collect the data. Now, the sensors sense the changes in the physical variable of a physical system or an environment that could lead to damage. Now, understanding damage is very important. Damage is defined as a change introduced in the system which adversely affect the optimum functionality of the system, either currently in use or in the future. So the damage is basically a change introduced into the system which adversely affect the optimal functionality. Now, basically, the damage or system change is defined as a change in the material property, the geometrical property, or also the boundary conditions or the system continuity, which adversely affect the system's performance. So therefore, as you all know, the damage, the sensors sense the data, the change in the data would define the damage. That's a basic definition of damage. And damage is not meaningful without a comparison between two states. So basically, when you collect the data initially, it's called the initial state, and after a few seconds, it's called as the post state. So when you see the difference, and there you find whether the structure is damaged. So therefore, the damage is not meaningful when there is no comparison between two states. Now, one must understand that the sensors cannot measure damage. So basically, in the initial days, when we used to go for the marketing or when we used to talk to the clients, basically they had an idea that sensor could measure damage and we could tell whether the structure is safe or not within a fraction of a second. Once the sensor is on place, whether you can find it, whether you can find the structure is damaged or not. But this was the situation when I used to talk to my clients earlier, wherein we were in a situation wherein we couldn't give an explanation, because if I give an explanation, I lose the project. If I don't explain, I'll be doing injustice to my job. So as you all know, the SHM sector was why the SHM sector is still not developing or still in the developing stage, because there is need of a lot of skill sets that needs to be provided. And this seminars or webinars will always help candidates to get the information and the knowledge, and further when they apply into their labs or when they work with their labs and they work with some projects, they'll definitely understand what is the amount of skill set that is required for structural monitoring. So basically, the damage assessment is a feature extraction through the signal processing, and statistical classification is necessary to convert the sensor data into damage information. That's very, very important. So therefore, we must know that sensor cannot measure damage, but the damage assessment is by feature extraction, or we need to get the information from those data. Now, basically, sensors must fulfill the A to E, A, B, C, D, E characteristics, which is as follows. The accuracy, the sensor should be reliable, accurate, benefit, and it should be having the benefits of being economical. Cost, it has to be, cost and compact, it has to be compact. Basically, it has to be as small as possible and cost effective as possible. Durability, the serviceability of the sensors should be durable. The express means the data operation and the accuracy of it should be fast, it should be high rate, and it should also provide the real-time measurements. Now, and as well, once we are dealing with civil infrastructure, it will also have the adequate service life as which is equal to that of the civil infrastructure. So the types of sensors that is available in the market are basically can be classified as surface attached, which could be glued, bonded, or it could be welded. It could be contact and non-contact. So basically, you have contact which are surface attached, and some are embedded, or some are embedded at a specific region, such as the damage or where there's expansion or a crack. So the conventional sensors, that is electrical signal based, or it is basically a traditional electronics based. So that is surface bondable, gluable, weldable, clampable, boltable, concrete embeddable, and composite embeddable. These are the these are the sensors that is conventional type of sensors that is available by various suppliers. And these are the few of the sensors that I've been using extensively in my projects, so earlier projects. So these are the sensors that is commercially available, and these are the sensors that I've worked on. Now, the conventional sensors have limitations in evaluating the long-term behavior, And that includes they are very sensitive to electrical noise. And basically this noise doesn't allow you to understand the signals properly, what is coming from the sensors. And this is always an issue. And also these sensors degrade with age. And presently, the fiber optics are identified as the most suitable for health monitoring of structures. As you all know, the telephonic lines are being converted from the conventional lines to the fiber optics lines. So as you know, the flow of data are quite reliable and as well as fast. The fastest, the rate of data transfer is also increased. Now, the advantages of fiber optic sensors are it is electromagnetic interference immunity. So basically, it doesn't, the electromagnetic radiations that are, it does not interfere and does not create any noise. It is lightweight. It's very small. As you know, that is it's also it is very small size for hair. Very low losses on the long span. Maybe for it goes with tens of kilometers. High temperature and ionization radiance tolerance, stability and durability against harsh environment, no local electrical power required at the measurement point, low resolution, high bandwidth of signal, and high sensitivity. So the fiber optics are also commercially available these days, and these are also again classified based on surface bondable, gluable, weldable, boltable, clampable, and then concrete embeddable and composite embeddable. So based on your particular situation or particular projects, you may have to define what type of sensor you require, and there are suppliers who will definitely suggest you or help you to understand the sensor and its limitations, and as well as give you the right consultation. As I said, this is a multidisciplinary activity. You may not be an expert in all the fields, but you need a lot of collaborated people, a lot of people with various domains expertise to get along and come to a complete solution for this particular structural monitoring schemes. So these are a few of the commercially available fiber optic sensors that has been extensively used in the products. Now, how many sensors to be installed is one more question. So, and it depends on the requirement, and it also depends on the budget and the time. So basically the budget is basically always need depending on the resources, and the resources includes the materials and the people involved, the time that is involved. So the higher the resources that is being utilized, the higher would be the cost. Because the data that is coming onto the from the monitoring scheme is going to be humongous. That's going to be very large. So the definition of the levels of sophistication can be described as in various levels. That is level 1, level 2, level 3, level 4, and level 5. So the first level is the existence. The first question that you would have in the mind, if in case, is there a damage in the system? And this could be answered by the level well detection of damage, which is you provide few number of sensors and you can say that there is a damage in the structure. And the next is the location of the damage. So this is quite a complex thing. So you need to process the structural data or the sensor data and then find the location of the damage. So that goes to the second level. Then the characterization of the damage, how extent, I mean, what is the extent of damage and how severe is the damage? That is the characterization of the damage. Now, once you know these are the things that you need to understand. So therefore the level 3, it's going to be a little complicated. You need to have more number of data processing, and then you need to analyze the data and interpret the data. So that's good. Third level. The fourth level is the sizing and the severity of the damage. How severe is the damage? And the fifth level is the residual life assessment of the structure. So basically the fifth level is extensively used in the aeronautic space and in the labs, but still, in the civil engineering, we are still in the third level. So level 3. So now you can see this one of the bridges being, most of the bridges that have been worked are in the level 1, and few are in the level 2, but definitely not on the practically. I've never seen, I've not worked on a structure that goes to level 3. So today we can afford to deploy few of the sensors onto the structure because of the reliable sensors and the number of cables that is involved, and that number of resources that is required for putting this structural monitoring in place. Definitely it is going to be a huge task because of the limited budget. But because of this, you can provide very few sensors, and that goes to the level 1, and you can see that it is going to just give you on the whether there is a damage within the structure or not, and it can just give you a little bit of warning and a little bit of failures, whether the structure is performing or not performing. It could give you an answer to it. But whereas when you want to put the more number of sensors to get the more complex analysis of the structure, the level of analysis is quite high. Therefore, the number of sensors is going to be high. That means more advanced algorithms is required. The more number of data comes in, and there is a lot of time that is required, which is going to be a little costly affair. And definitely, this is not this is a doable job, but it depends on the situation where it is required, the need also for it. So the third component is data acquisition system, and we all know that data acquisition system can be classified as portable, fixed, and handheld, or it could be also defined as online, offline, real time. And these are the various classifications. And basically, in the market, you get data loggers, data acquisition devices, and data acquisition systems. So the classifications and their benefits are just shown in this, and I will try skipping this slides and just show you and introduce you to these systems. Now, these are the few systems, that is portable, handheld, and online monitoring systems that are permanently installed onto the structures. I've been working with these systems. And the data transfer always takes through cables and the network of the sensors. Sensors are networked to the data acquisition system. The data acquisition system, which is centralized, will also transfer the data to the remote servers also. So basically, you have the centralized data acquisition system, wherein the parallel connection to the there is a parallel connection to the sensors. And this type of acquisition system is used in labs, and it is used in small projects. But when it comes to large project, when you have a minimum of 20 sensors, or maybe about 10 sensors onto it, and therefore the number of cables that runs onto the bridge itself is going to be quite high. And if you're monitoring a small system within the lab, which is very flexible, and trying to monitor the damping, because of your cable and the weight of the cable and the weight of the sensor itself, the results you won't be able to get. Excuse me, I just have to mute a few people. Just hold on, please. Yeah. Yeah. So the number of cables that goes because of the sensors and the number of cables, the parameters, the model parameters, there is going to be a different, and it won't give you the right results. So therefore, there are a few developments that has taken place. That is the distribution data acquisition system can be converted to the series connection, which would help in the projects wherein this is a large span structure, or structure which is short span, but we need minimum number of cables that runs onto the structure. In that scenario, we need to go with the distributed data acquisition system, that is a series connection, or the bus topology. So this type of instrumentation is being developed, and there is also presently that the wireless technology that's come, that at every sensor you have a node, or you have a centralized you have the distributed DAQ, or data acquisition unit, placed very close to the sensor itself, and that transmits the data to the remote server, or remote server and remote station. Therefore, the data are going to be stored. So you can have various type of networking that can go. It could be cabled, it could be wireless, and there are different type of wiring. It could be fiber optics, it could be the normal coaxial cable, shielded, unshielded. So there are various type of wired networks and wireless networks that have been extensively used, and you can go with various combinations of networking. So basically, these data are networked, and then the data are transferred to the data acquisition system. From the data acquisition system, it moves to the remote station. So basically, there are the bus topology, or the series networking DAQ, which I was previously working in my previous company, was based on the networking of sensors in series, which was one of the most which has its own advantages, and it has its own limitations. So this was extensively used, and most of the projects which I'm going to talk about today, I've used this type of networking scheme. So this is inspired from the networking scheme that is there in the fiber optics, wherein in the fiber optic scheme you have multiple sensors in one single strand. You have multiple type of sensors, as well as you have the multiple sensors that are there in one particular strand, and that can be monitored, and that can go for a long run. So this is one of the examples of monitoring using the fiber optics. You can see that in the right hand picture, you can see that the structure that has been the very old ancient structure that has been monitored for the expansion due to thermal. You can see because of the thermal, there is a lot of movements, and they wanted to monitor the displacements of it, how the temperature is affecting this particular structure. You can see there is one cable network that runs through it. It's a bus topology, and they're monitoring the displacement at various points. There is an extensionometer. You can see there is an extensionometer at every point that is provided. So therefore, they're monitoring how the temperature is affecting this particular structure. So how much of data is collected? As you all know, we have two situations presently in structural engineering or civil engineering infrastructures. That is, we have the structures to be very large. So the structures are very large. The number of sensors are going to be quite high, and because of the number of sensors are high, therefore we have the large amount of data that is coming from the sensors that is spread across the whole infrastructure. Therefore, the situation is on the deployment density. So the second one is that long-term behavior, because our civil infrastructure does not deteriorate within a fraction of a second, but takes a long situation or a long period of time. Therefore, it has to be monitored continuously over a period of time. So therefore, the amount of data is going to be humongous, because we are going to monitor continuously for many years, say about 20 years or 30 years or so. So, but it has to be monitored for the entire service life, which could be about 50 to 100 years. Now, so both of this have got two issues. The first reason relates to the issue of sensor deployment, that is, more number of sensors are deployed onto the civil infrastructure. And the second relates to the frequency of monitoring, which is that we need to monitor continuously, and we need to monitor at a particular rate, and the amount of data has to be monitored for a longer duration. So how much of data is stored? That's the huge thing. And these days we are in the 5G technology, and the data transfer is going to be almost 100 times when it compares to 4G network. But where are these data transferred? As you all know, your phones these days are enhanced with much of memory, but the photography, the resolution has increased. You have a 48 megapixel camera that is storing each picture about 13 MB or so. Similarly, when you have the high rate of data, that means high rate of data, high resolution of data, or the number of data that is transferred per second is high. Therefore, the storage also is going to increase. Therefore, they need the humongous data that is required. So therefore, the storage of data, if in case you take a present day situation that the maximum bit is going to be 24, the practicing in the labs are 8-bit or 16-bit. But here we have the high resolution bit samples of 24. And there is, let's say there's one channel that is x-axis vibration data that is being monitored, and you're monitoring for about 60 seconds. And per every 60 seconds, you're collecting 100, per every second, you're collecting 100 data. Let's say that's called sampling. So per every second, you collect about 100 samples, and then you can see how much of data is being stored. So I'm collecting the samples, 100 samples, and you can see per minute that per every 60 seconds, if I'm collecting the data per second, I'm taking 100. That means you have 17 kilobytes, almost 18 kilobytes. And if I'm collecting per year, you can see all just for the one channel, and for every sensor you'll have 3 channels, or sometimes you'll have 2 channels, and therefore you can understand how much of data is going to come in play. So you have almost here about in MBs, you can see here, if I'm monitoring per hour, you can understand this way. If I'm monitoring a sensor per hour, I'm collecting the data on a civil infrastructure for 100 samples per second, or rate of sampling is 100. Therefore, you're collecting almost 1 megabyte. So this would be the better number to understand. So there are going to be at least minimum of 20 sensors, let's say, and you can calculate, and most of the large structures will have at least hundreds of sensors onto the structure. So the last is the data management. Now, data management is a crucial thing in data analysis. As you all know, these days most of the civil engineers or various sector people are jumping into data analysis, and there is a lot of marketing that is done on data management, data analytics, and big data analysis. So these are the present day trend, and therefore, why is that so important? Because we have so much of data that is coming in, and we need to look into various things that are important, and this falls into the category of data management. And one most thing that is of a concern is to retain the data for a longer duration. The longer duration in civil infrastructure is going to be a minimum of 20 years, and it has to be monitored at least for this lifespan of the structure, which will be 20 or 50 or 100. So the storing these data and analyzing these huge data is one more issue. So therefore, the last one is the data analysis or the diagnostics. So you have the data that, so if you look at the above figure, your data is the first image, which is scattered. Now, if you want something specific, such as the particular record in a database, it becomes cumbersome. So to simplify this, you need analysis. With analysis, it becomes easy to strike a correlation between the data. Once you established what to do, it becomes quite easy for you to make decisions, such as which path you want to follow, or in terms of business analytics, or which path will lead to a betterment of the performance of the structure. That could be also seen as a structural health monitoring. So, but you cannot expect people in the chain above to always understand the raw data, because you might be an expert in understanding the data, but not all that are involved in this particular projects will understand the raw data. So you need to provide them the data in a most systematic way, in a most simplest way, and that basically falls in data that falls after analytics. It falls into data visualization, which needs to be simplified. Therefore, your end user, or the people who are going to take decisions, or people who want to get into this business, like those people who are looking into the seminar, I'm not providing you all the basic raw data as what we have done earlier and how we have done, but basically you look for the data that is simple to understand, so that you can make your interpretation. But this many things are getting into play when we are doing a structural health monitoring business. So next is the data visualization. So data visualization, as I said, it has to be as simple as possible, and the large amount of data should be captured in a most simplest way, so that you get the most complete understanding of that particular situation. Now, utilizing the structural monitoring tool can give you more time to focus on the data interpretation, evaluation, and action, with less time spent to acquire it. So basically, when you take up the traditional one, you need to go onto the site and collect the data, and then at every specific intervals you need to keep monitoring on that, a calendar check on that. You need some type of people moving about and getting those data, and basically you would take so much of time only for those. But these days, implementing these structural monitoring schemes gives you more time for the data interpretation and evaluation and taking further actions. So the slides provides you an example of measurement, interpret, present, and action. So basically, let's say you have a particular situation wherein you need to monitor the temperature, strain, displacement, and the speed. You will select a few of the sensors from an expert who is an expert in sensor, and you deploy that. You'll get a structural monitoring expert who will try to give you a complete package, and thereby you get the data on site. So you get your data on your particular server or your particular drive, and then what you look into is you look into the data. So if in case you're you're also good in signal processing, you can process the data and get into the information and get the interpretation done by an expert. Then if in case you're looking for a structural interpretation, you can go for a structural expert. You're looking for an environmental interpretation or hydraulic expert can hop in and they can give you their interpretation. So basically, you try to convert the data into information and you make an interpretation. And once you have an interpretation, say if in case you make a report of it, or you pass the data to the people who are supposed to be informed, or supposed to who are the people who will dictate terms and how what needs to be taken, what needs to be done. So they will take the interpretation or understand the information from that, and thereby they will take the action. So if for those people who are involved in civil infrastructure, the action could be how close is the structure behaving to that is being well designed, whether the structure needs some maintenance or retrofitting scheme, and these are the information that you would collect from this interpretation or informations. So basically, this would have given you the idea of what is the structural health monitoring and what it is composed of. So basically, in the first initially I explained on global warming, and that has been changing the situation and across the globe. So because there is a change, there is going to be damage, or there is going to be deterioration. Thereby, we need some type of tool, and structural health monitoring is the right tool for the present day situation. And we also learned the structural monitoring is nothing but a multidisciplinary activity wherein you have multiple disciplines getting together to form a complete system. Now, this system has got its own complexities, but all that you need is a simple interpretation of the data, the converting of the data to information, and therefore this system is definitely helping because it gives you more time on the interpretation part or the analysis part rather than the routine things that needs to be done. So basically, the structural monitoring system can be designed to answer two distinct problems for the present day. That is, it can act as a warning tool for the existing structures if in case you try to provide these structural health monitoring systems onto the structures. So therefore, it gives you it works as a warning tool if in case it's already constructed, or also for those structures that are still in healthy state can also act like a preventing tool in the new structures or in the existing structure. So therefore, these structural health monitoring systems can act as a tool, and this is definitely going to be a best solution or a best way forward for the sustainable development of the civil infrastructures. Now, the significance of monitoring the temperature humidity. So now I will touch upon this particular topic, that is temperature humidity. Now, the temperature humidity sensors are most commonly used environmental sensors in any structural monitoring scheme. So all this while I was talking about what is a monitoring system, now I'm going to looking into only two specific things, that is the temperature and humidity monitoring. This is extensively used in most of the projects, and I've been using this particular technology way before. So now humidity sensors are also sometimes called as hygrometers. So if in case you are aware, and whenever you're monitoring the structural parameters, the ambient temperatures and temperature, basically temperature, you have two types of temperature in structural engineering or in civil engineering. You have the ambient temperature, which is nothing but the surface or the surrounding temperatures, or the ambient temperature. And next is the the structural temperature. Structural temperature could include the core temperature or the surface peripheral temperature. That means the outer part of it, structural temperature that is in contact when the sensor is in contact with the body of a structure, then you are acquiring the structural temperature. Now, as you all know, the climatic change is always rapid, and whether the weather change is going to be rapid or the situation, that is the temperature of the ambience, quite changes drastically, and it's quite dynamic. Whereas the fluctuation of the structural temperature is going to be a little slow, or in the core, it is going to be relatively very, very low or relatively constant. So both of these are measured in Fahrenheit and Celsius. So basically, whenever we talk about monitoring of temperatures, we can monitor either the ambient and the structural temperature. And when it comes to structural temperature, we have the surface temperature as well as the core temperatures. When it comes to relative humidity or the humidity, we need to understand the definition humidity, then the relative humidity. So that would give you the complete understanding of what you're monitoring. So basically, in most of the cases, the census that is available measures the relative humidity. The slide will provide you the complete understanding on this particular thing. Because of the lack of time, I would try to skip this definition. But anyway, you can pause the videos whenever it is recorded or uploaded. You can always pause it and get to know, or you can always look into the Wikipedia. That will give you the complete understanding. And these informations are collected from various sources. So therefore, it's just you need to have an idea of what I'm talking today and what you're supposed to know. So the relative humidity, otherwise mentioned as RH, most of the time it is called as RH, is the ratio of water vapor present in the atmosphere. So therefore, most of the time we basically monitor relative humidity, and it is used to determine the change in weather conditions. So basically, the humidity is measured as the water vapor per cubic meter, whereas the relative humidity is measured in percentage. So basically, you will see the measurement in temperature. So now, during COVID-19, the situation, all of us have understood the importance of monitoring temperature. So everybody knows its importance. That's very, very important. Thermal screening, and most of you know that the thermal screening had taken place at every corner and every individual houses. The thermal scanning at every security checks and the thermal screening and scanning are the first step to detect fever, and the first preventive measure, or the first step to the preventive measures to isolation. And on the post detection, that is, once it is being detected, the constant monitoring of the isolated person is important. So this is, the importance of temperature monitoring. So that the temperature monitoring has been really helping people to understand whether you're COVID positive or negative. It also gives you how well you're coping up with the situation and how well you need to, when you're in isolation, and this has been extremely understood. So, but this is the thing that we understood during the COVID situation. But if you look at the data, that is the widely searched, the extensive research and mostly widely searched related temperature issues during the COVID-19 in closed down was also this particular thing, the ideal temperature to cook chicken in the oven. So most of my friends who were being at home locked during the COVID situation, although they knew the importance of monitoring the temperature when they are sick, but few of them were not sick. They were quite happy because they were completely isolated. But if you look at the search engine, or you look at it on temperature, what is most searched, the temperature to cook the chicken in the oven, the right, because most of them wanted to become good cooks, and this is extensively searched. And what I thought is, why don't I put some more for the benefits for the those people who are also vegetarians, vegetarians, and those people, they will not feel bad because I gave the secret of cooking the chicken. But therefore, I thought of adding these. So the temperature is quite important even in your kitchens. So maintaining the right temperature for the right cooking purpose is important. So I just added a few of those because I was looking for the most searched temperature during COVID. So these are the things that I got, and I think this would be quite helpful for those people who are experimenting on cooking. So I would emphasize that kindly look into the importance that is given for the temperature. Now, why I speak about this is, when you cook at this right temperature, you would get a right dish. Or if you don't cook at the right temperature, you will not cook the right dish. Similarly, if you don't try to monitor the temperature, you will end up elsewhere. So the temperature monitoring is very, very important. Now, the temperature measurement is not new to a few of us. We were in the 90s. There was a movie called Predator. Now, temperature monitoring was done by these aliens. The scanning of temperature was done by this alien on the captured human being. So it could sense, it had the infrared vision or infravision. So I will just run through the clip. You can see that in the COVID situation, as you all know, most of it were asked to go for the scanning, but this scanning is not new to those people who have seen this movie, so they would have understood. Now, the present day situation is that initially few people were grabbed and they were scanned, and progressively most of them volunteered themselves to be scanned for their temperatures, and presently we are all automatically scanned for temperatures. That's the situation we are in. So slowly we are progressively moving towards automatic scanning for temperature. Similarly, the structural health monitoring is getting automatically, that means the sensors are implemented in the structures, and they're being automatically scanned over a period of time because of this, the low cost IoT technologies. Now, the monitoring devices and technologies have improved over time, and temperature measurement, which was earlier, was quite different, is now becoming faster, accurate, and smart. Now, you can use your smart mobiles with an attachment to it. You can also screen the thermal ambience also. So this has been extensively used in various schools abroad and to most advanced schools. So the temperature measurement, when it comes to the temperature measurement in civil engineering, or the most commonly used temperature sensors are those like thermistors, thermocouples, then RTDs, and the IC-based or semiconductor-based sensors. Now, the slides provides you the various advantages and disadvantages of using various type of temperature sensors, but whereas the thermocouple and the transistors are extensively used, as you can see that these are the extensively used in most of the products. Now, when it comes to humidity sensors, there are three common types of humidity sensors. You can talk to some of the electronic guys or the sensor department. They'll give you a complete understanding of these and their limitations. So it is capacitive and resistive and thermal based are extensively available, and it's been presently available in the market. And the development of the humidity sensor is going at a faster rate. And you can see these are the data that I've got from those people who are working in this sector, and there is humongous there is a huge development that is taking place on this particular sensor. So that is being extensively used, that is a humidity sensor. So you have the various types of sensors. It could be optical based, acoustic based, and electronic sensors. So we see most of them are still in the development stage, and few of them are already in the market. Now, most of the time, the temperature and the humidity are measured together. So we know that in a COVID situation, we used to measure the temperature, and humidity is measured in most of the situations and most of the places in order to have the complete ventilation, aeration, ventilation. So therefore, both of these combined also it helps you in understanding the potential effect of heat index. So now the table what is being provided to you indicates the possible complications at varying level of heat index values obtained from various resources. You can refer to Wikipedia mostly. The heat index is a temperature equivalent that is pursued by the human as a result of air temperature, relative humidity, and wind speed. And as you all know, if you walk in the streets of Delhi or any places which are hot now, which is not locked, you'll understand, when there is an air blowing and there is a relative humidity and wind speed, you will feel the heat. Okay, that this temperature can be potentially have severe medical effects, and that effects are being indicated in the table beside. So you can see that that what degrees, how it affects the health. So basically, you can see at 27 to 32 degrees, the fatigue is possible with prolonged exposure. The continuous activity could result in heat cramps. So basically, if you are referring to this particular table, on the you can see the temperature is on the x-axis and the relative humidity as y-axis, and you can see how caution you should be: extreme caution, danger, and extremely danger. So looking at this chart, this chart can be used by various peoples in various field for various things. But if you have understanding on these things, that is, you have an understanding on these things, you'll be able to appreciate the measurement of temperature, humidity applied onto the structure or any other situation. So now, also the significance of measuring the temperature and humidity is also completely defined in the Indian standard. So whenever you are trying to do some experimental tests or any type of experiments, or we are doing some type of lab assessment, there is a clause that is given in ISA 196. So it is published in 1966. It is a Indian standard on atmospheric condition for testing. So it very clearly states, and there are ISO books also that also states the same. So you can refer to this. That gives you the importance of temperature and humidity. Now, if you have worked with various other sectors like aeronautics, automation, defense, or energy, or the telecommunication, or various other fields like biotechnology and other things, so you'll be having a fair idea on the temperature and humidity testing. Now, the temperature and humidity testing basically determines how components or the complete system behaves in a severe environment that involves elevated temperature and high or fluctuating relative humidity. Basically, the test can be static or it could be dynamic. That means there could be varying temperatures or varying cycles of both temperature and humidity. And basically, this type of testing is done. And most importantly, the 85-85 test, which is also known as a damp heat test, attempts to stimulate the 20 years of moisture ingress into a given product. So basically, if you basically do this particular test, 85-85 test, so this would give the rough idea of the aggravated or accelerated 20 years moisture ingress testing. So the number is just an approximation. That is you're just trying to see at the higher elevated temperature and higher elevated humidity, what is happening to your component. Basically, it is also called as temperature humidity biased reliability test. Basically, this is a reliability, how reliable it is going to be at the higher temperature and humidity testing. So therefore, you would have understood by now that the significance of measuring temperature. You have learned from the books that most of the definitions says that, if you define any particular physical experiment, you say that provided the physical and the lab conditions are constant. What are these constants? This is nothing but the temperature, humidity have certain specifics. It's already given in the code book, that is IS 196. And when you are also trying to check whether your components of any structure is reliable over a period of time, you can do the durability test or accelerated test, that is 85 test, or the temperature humidity bias reliable testing. So that will give you the performance of a particular system on the elevated temperatures and humidity. So the significance of temperature and humidity for a basic civil engineer who is working on site also knows its importance, because in most of the civil engineering projects, concrete is the key ingredient of construction. Monitoring the temperature of the pour after the placement is one of the most important steps in the construction. So the ensuring the optimal curing condition for this is critical, as you all know, especially during the extreme weather conditions. So therefore, whenever you have the extreme weather condition, the hydration process is going to drastically affect the strength properties or the shrinkage properties of the structure. Therefore, you need to monitor the temperature and the humidity. The next one is the significance of the temperature and humidity is also well known or well aware in civil industry because of the mass concreting. Now, because of the mass concreting, there is going to be volumetric shrinkage, and because of which there is big the cracking in the mass concrete due to thermal change. So this is a basic definition that everybody knows. And if in case you don't know, you just have to Google for the mass concreting and the thermal effects. You know that the concrete is basically a good insulator. It does not allow the heat to pass through it easily, but the hydration of cement is an exothermic reaction. So there is going to be a difference in the temperature between the extreme outside and the inside. Therefore, there is going to be a change in the difference in the temperature, and this would cause the shrinkage, and therefore, the whole cycle will be different. So therefore, there is going to be a lot of shrinkage that will cause cracks to occur. So therefore, the monitoring of this temperature and humidity is a must when it comes to mass concreting. Now, the significance of the temperature or humidity are also important in few of the sites where the structures are in the most corrosive region or most susceptible to corrosion. So, such as the seaside or the metals or the structures that is being exposed to salt water, where the rate of corrosion is very high. So, this is one of the structures that was existing to very highly corrosive zone, and most of you have already taken a guess of it. And this particular structure was in the highly corrosive region, and because of the aging, highly deteriorating process and the aging process, the structure was highly degraded. So because of the degradation, there was extensive retrofitting that was done, but these retrofitting, although the structure is already into the worst situation, that is it's in the highly corrosive zone, and it is highly humid and the temperature is quite high, and the choice of retrofitting is also important whenever you're doing a retrofitting scheme, and you have to take care of the temperature humidity. But this particular situation, as you know, when I had an opportunity to visit the site and we were supposed to provide some services, the structural health monitoring, I could see that it was post-tension. The external post-tension was applied for the retrofitting scheme of it. But anyway, that's the only option they had. But this was also, as you all know, the post-tension scheme is prone to pitting corrosion because of if it is in the highly corrosive zone. So exposure of metals to the moisture, especially the sea salt or sea water, or the high humidity at high temperature will also increase the rate of corrosion. Now you can see the closer view. You can see the exposed post-tensioning scheme that has been already corroded. Although it has been newly retrofitted, still it has been corroded extensively. Now you should also be aware that the corrosion or the speed of corrosion the rate of corrosion is dependent on the humidity. So the percentage humidity. With RH over 60%, the rate of corrosion on steel rises rapidly. That is a well-known fact. At the RH of approximate 50, virtually no corrosion occurs. This is well known. But you also see the temperature. Now, as a rise in temperature increases, the rate of corrosion as the RH and the temperature are interdependent. So basically, you have the relative humidity. You can see here the 100% relative humidity, what is happening with the air, water in air, and then the temperature. Because of the temperature, we can see that the corrosion also increases. Therefore, these are the major contributing factor, and the temperature and humidity are prime important whenever you design the civil infrastructure. Now, this is a bridge in Canada that is the busiest crossing that is cracked, and you can see various surface is being cracked. And this surface deterioration are just some of the problems that you can see across the streets, along the streets of the particular country. This is because of the use of road salt during the winter. So it is basically, it is considered as one of the major contributor to the corrosion and deterioration. Okay, now the next question comes to your mind is, they don't have the surface treatment. Yes, they do have a surface treatment, but these sealers or cures, the sealing cures, which is being extensively used, also depend on the temperature, humidity level, because their efficiency depends on the temperature and humidity level. If you are not taking care of these things, your sealant is not going to be bonding, and there is not going to be proper effect on it. So there is not going to be any proper effect. Therefore, you'll see the temperatures and humidity levels are also important when you're using the proper sealant. Now, this is one of the bridges that has been affected to fire. Because of the fire, there is you can see that the bridge underneath was subjected to the fire. So, and during fire, there is something called the spalling effect. That means the surface of the concrete cover is going to split, that's going to spall out, and it's going to be, like exploding. Actually, basically, it will be exploding, and this is called the spalling effect, or exploding explosive spalling. This is because whenever you have the temperature between 150 to 250 and above, that is 400 degrees, the calcium hydroxide of the cement hydrates and creates the water stream. That's the basic thing. So this water stream, what it does is it tries to increase the pressure, and thereby it pushes the whichever is the weakest section. Therefore, you basically lose out the concrete on its surfaces. So therefore, when you see, there is a lot of monitoring schemes that is done to understand this particular situation, that is the explosive spalling, for which what they have done is that they have put some sensors into it, that is a temperature and relative humidity, and they have made some studies, and they've used the acoustic emission, and thereby you can see very clearly the areas onto the left of your screen. If you see that, it indicates how the temperature and the relative humidity are affecting the spalling, and what happens with the elevated temperature, and how the whole situation is going to be. So basically, this explosive spalling is again dependent on not just the fire temperature, it is also dependent on the what is the RH, the relative humidity, and as well as the temperature that the structure is subjected to. So then the water content that is there within the structure. So this says the importance of temperature, humidity. And therefore, if you see, this is one of the bridge in China. It was built in almost in 2013. And if you see the day it was built, there was a lot of cracks that were formed. About 200 cracks to 300 cracks were seen underneath the bridge, and it was all superficial cracks. But there was a huge research that was done, or investigation that was done. It was found that because of the due to the relative humidity and temperature, the more shrinkage strains that changed because of the temperature. They concluded that the humidity effects on shrinkage is the main primary cause for this particular cracks that happen. That is, when the temperature rises, that moisture in the concrete diffuses more rapidly as humidity descends, results in larger concrete shrinkage. This was the conclusion that was provided from the particular study. So therefore, we also know the importance of temperature, humidity, and I've told you about various situations now. So now there is also one more situation with which is a typical known major potential damage to structural element of simply support bridge. This is extensive studies done in US and in Texas, actually, basically, and they have come up with a report stating that the combination of clogged joint condition and unpredicted thermal stresses this could actually deteriorate the bridge because of the local buckling that happens, and there could be the other issues that is related to because of the temperature variation, as well as because of the clogged expansion joints. So you can see that buckling of the girder flanges, spalling the abutment, and deck cracking. So these are the primarily seen things because of, this is all because of the temperature and because of the clogged expansion joint. So we have understood now how the importance of both the temperature and humidity. Now let's look into the case study on the understanding the need for adequate performance. Now, as you all know, there is a disaster that happened in 2007. There was a failure of I-35 bridge in Mississippi. There were 13 deaths and 144 injury. And you know the major cause for this. And this is a video that is floating. I'll just skip this and I will go and get into this. This particular bridge had the very well documented investigation protocols. That is, it was investigated every yearly and then every quarterly and then every monthly post its construction in 1967. It was monitored regularly, and it was monitored by various set of teams and different teams basically over a period of time, and they were rated as poor but not critical. These two words are quite different. So rating it as poor and rating it as critical are two different words. It means a lot. So it is going to be changing. So everybody are in now, that if a doctor says you have a poor lung condition, that is different. If you say it's a critical condition, then you know the difference. So therefore, even the structure was in a poor condition or a critical condition, it was different. But the bridge was rated as poor in 2003 and 2005. And it also, the report documented that the residual life or the remaining life of it is almost 10 to 15 years, and they also estimated the structure to be constructed in 2020 or 25. But to the unfortunate thing that happened within the 2 years of this report is that the bridge collapsed within the 2 years after evaluation. That is on the August 1st, 2007. So basically, this happened because of the unnoticed failure of one of the gusset plate that was bent, and also the various other situations that was not looked into. And this structure was already built in an era where the structural analysis was developing. I'm not talking about structural monitoring, but structural analysis. They never knew the structure being they didn't learn much on this structure, which was basically they would fail because of one of its system. If it fails, the whole system is going to come down. And such a structure was called non-redundant structure. So this was a non-redundant structure. And if you look into the theory or the history of analysis of structures, you will get to know that in the 1967, I believe, that the non-redundant definitions was given, and then so when the definition was given, the structure was already constructed. Therefore, that definition was not known by the designers. Therefore, the definition is that whenever there is one single failure of a member, the whole structure is going to fail. So that is the definition of non-redundant structure. This structure was non-redundant because of the design issue. The second thing is that because of the inspection and the other things, they rated it poor but not critical because of the changing teams. They had their own perspective, they had their own subjective analysis of this particular investigation, and therefore they also had some various uncertainties that they were involved. As usual in any civil infrastructure, it is not high, we can't easily predict the failures, but we can also already say the probabilities of its failure. Therefore, the structure failed, and this was attributed to this particular thing in the final report, that the bent in the gusset plate caused, and the deterioration caused the bridge to come down. So, as you all know, but ultimately we lost the bridge. But in the recent days, there is also the very recent that I'm talking about this month. there was a failure that occurred in one of its bridges in USA. I'm going to go with the case study. So previously in the case study, we understood that performance adequate, although the monitoring was done, the inspection was done properly, but still we lost the bridge. But recently the bridge was investigated and found to be unsafe. So let's look into this case study to understand the need for monitoring temperature, humidity. And let's understand why there is a need to monitor not just the parameters of the bridge, but also of the humidity also. So now this is one of the bridge. You can see that it's a interstate 40, it's called as I-40 bridge over the Mississippi River, and it was shut down indefinitely. It's not known still when it is going to be open due to the crack found in a routine inspection on Tuesday, May 11th. I'm talking about this month, 2021. So the day when I agreed to give this presentation, I was reading the report on this. So luckily, that's why I tried to formulate this particular presentation. That's why it took so much time and to formulate this presentation. So this is the latest Interstate 40 bridge or Mississippi River. You can look for it, you can Google for it. This is being presently shut down, and it was shut on May 11, 2021. So basically, there is a video which I can, if in case there is time, I can run through it. Okay, let me run through it. And this gives you the basic idea of this bridge. This bridge was opened in 1973, and it was built in the area that it was designed for a volume that the present day it is taking much of the higher loads. So basically, it is subject to most of the fatigue loads, and the fatigue is not necessarily by the loads of the traffic, but it is also because of the temperature. So since 1970, I'm talking about. Okay. So as you all know, this is also situated in the worst seismic zone that had a magnitude earthquake of magnitude 7.8. So because of this, because of the initial investigation, they found that the structure had some deficiency. What they did is they tried to close down the bridge, and basically everybody who were involved, the coast guards also closed down the waterway underneath the bridge also. So these are some of the slides, pictures that says what is the present situation. And the traffic was diverted because of the situation on the bridge. And as you all know, the prior to this closure, there was a constant monitoring that was taking place. That was the routine inspection was done. The number of vehicles that crossed was about 41,000. So vehicles crossed every bridge, and 30% of it was the commercial trucks. Now, the bridge was inspected regularly, and during the inspection, they found a major crack in the bridge, and it was reported. And immediately, the inspectors took immediate action. The bridge was locked for traffic movement. So the crack was looking mostly like a fatigue crack due to the thermal contraction and expansion, additional to the dynamic load that comes from the vehicle traffic. You can see that slide wherein I've marked the red circle, and there is a crack. I'll show you some more things. You can see this here. You can see the slide. There is a crack over there, and then you should note that the fatigue is a failure mechanism that involves the cracking of the material and the structural component due to cyclic stresses. Now, one of the factors about fatigue development is that the fatigue crack can be initiated and propagated at the stress well below the yield of the particular material. Not necessary it has to cross the plastic deformations. Okay, it's not necessary, but it could be within the elastic deformation, but it will definitely undergo fracture. So you can see here the critical beam of this particular structure was fractured, and it is completely sheared basically. So almost, this particular beam, what you're seeing is actually a box beam, and what the reasons, if you are all bridge engineers, why the box section is provided at this point. It will give you a clear idea. And this particular steel box is cracked. This is completely sheared, and it is broken into two halves. Now, the critical beam was fractured very closer to the support. As you can see, there is a joint. You can see here, there's a bolted on the joint here, and there is a crack over there. Now, if you can see from the photograph itself, it gives you a clear idea of the extent of the corrosion that has taken place and the time that would have taken place, right? So now, you can see further closer to that, these are the cracks, and this is the distance in the dimension of the crack. So you can understand the importance of this being closed. Now, as you all know, there are several factors that influences the fatigue strength. That includes the range of stress, and that is dynamic stresses, and the geometries or the static reversal stresses. The geometries of the component, very important, and the material property, and the environmental factor are very, very important key points. The fatigue properties, as you all know, what basically a designer does is they go with increasing in the thickness of the component, whereby they make it fatigue resistance. But you should also note that the increasing thickness can result in failures being brittle rather than ductile. In most of the civil infrastructure, we expect a ductile type of failures. That's why we go in for under reinforced structure. So that is a that is a note that you should note. When I was observing this, I thought of getting into my fundamentals and understanding the situation. So this, you can see that few of the workers are looking into the inspecting the cracks and how this would have happened. Now, by the experience and various situations that I've gone, by the situations, now I have understood that the numerous investigation indicate that temperature is a critical source causing the variability of vibration properties. So most of the vibration studies, whatever I've done on the bridges, what I've understood is that the model properties are not just influenced only by the loads, but basically it's more influenced by the change in the environmental conditions such as the temperature. So even if there is a damage, now the damage cannot be easily captured by these sensors or structural and monitoring schemes, because the frequencies, the frequency or the change in the variations in the model frequencies because of the temperature itself is going to be quite large. So thereby, that the importance of the need of the performance assessment, and then now the importance of temperature and humidity, and we saw that the temperature and humidity also has to be monitored for any type of situations like this, because we are looking into the importance of temperature, humidity. So therefore, you understanding this, so taking the failure studies, we have understood the importance of the temperature, humidity, and therefore we'll look into two of the projects that I've done, and I'll run through the slides. And this is a project in Bangalore, wherein this is steel bridge, and the same situation, we have given the site, we have given us to install some sensors and monitor, because they had the objective of monitoring was different, but what we captured is quite astonishing, and I had a complete insight into the structural monitoring. And this was one of the first projects wherein I did silly mistakes and was able to understand better, get better insight into structural monitoring. These are the sensors that I've been, you can see that, I'm onto the this particular crane and trying to install and instructing the particular persons to install the sensors there. And you can see one of my friends on the roadside, I was taking the pictures from a long distance. You can watch him, so this particular bridge, we installed various set of sensors, but the importance, what we were told is that we were told to just to monitor the strain, but knowing the subject, what I intended to do is, you can see that I'm monitoring a weather station here. Okay, so I was asked basically most of the questions by most of the engineers that those days, that is, I think it was in 2009 or 9, when I was installing this first sensor and the humidity. You can see see here, I'm installing the temperature and humidity sensor, the surface temperature, and then we are also in here in the next below slide, if in case you're not able to see on the laser, you can see here I'm installing the structural temperature sensor. This is the surface ambient temperature, and this is a weather station. This is a tilt meter, and we have various strain gauges that goes below this joint. So these are the sensors that we monitored. So look at this, we had no idea at the time that what we are trying to see, but basically we had the basics strong. So you can see that this is the tilt change in the X direction. This is a tilt change in the Y direction. There is no load that is coming onto this particular structure that we are monitoring. So basically there is no load onto this. Because of shortage of time, I will not run through every details of it. Now you can see here the variation in temperature. This is the variation in the ambient temperature. This is a variation in the structural temperature. You can see there will be a lag in it because of the change. There is going to be a dynamic change. We had a dynamic parameter monitored here and the static parameter monitored here. You can see the variation of because of the weather itself for a 24-hour span. So you can see why the tilt is changing, why the deflections and the strains are changing. You can see the correlations between the temperature and the strain that is happening onto the bridge. And this is the the outcome of this is that it was observed that the response of the bridge to thermal variation due to ambient temperature is considerable. This was the first, I have this report that is already published to the clients. So you can always refer to this if in case you would like to know. And this is with the MCF, said Bangalore. Okay, now the measurement at the bearing location though. So this, the objective was quite different. I'll skip all those objectives. So we also said that it needs to be monitored for the corrosion and the impact of being located in the corrosion zone. We need to also monitor the temperature as well as the humidity continuously. So basically we also updated the design of structures are quite complex, and the influence of temperature is one of the essential factor in the design process. Such temperature stresses due to temperature variation has great impact on the structures. As we all know, whenever we design a structure, we use the uniform distribution, whereas in reality the structure, because of the non-uniform temperature gradient, there is going to be major change, and as you saw, there's going to be stressing and strain that is happening and the fatigue that is going to happen, and therefore there is going to be a maximum changes in the structure. So this is rarely considered in the details. So we also updated the designers. I think these people are Jacobs. Most analysis assume a uniform temperature. As I said, the difference between site experience to calculate the temperature stresses in the thruster is very long. The design method may lead to unsafe design. This was the conclusion we have provided. So basically, we also emphasized on the corrosion point of view. We also emphasized on the entities that needs to be done regularly because of anticipating and because of experience. And you saw already the bridge that was monitored has failed without any notice, and because of the visual inspection, not the sensor-based inspection, they are able to find. And as I said, if the fatigue failure is not because of the traffic loading, but whereas because of the temperature. The next situation is in the online monitoring of a Neva bridge. This particular bridge was, this project was allotted to us from the commission, the construction stage to the present day. So this is located in Russia. As you can see, I'll run through this. This is a dual bridge, and it's a steel twin bridge. And because of twin being close to each other, you know, the aerodynamics is quite a bit complex, and therefore the aerodynamic study was done. This is the designers of the bridge, and the span and the geometrical details are provided here. And this is a beautiful bridge. It's worth watching, and the traffic has got the 4-lane on each bridge, so you have one-way traffic on each bridge. And this bridge is quite complex. The aerodynamics, to understand the aerodynamics and the coupling effect between the towers, and between the towers the air passes by, and therefore the aerodynamic coupling has got a major impact on it. Therefore the analysis was to be done using the wind tunnel, and the same has to be also monitored on site. And because of the temperature that is going to be in Russia, the temperature is going to go below minus degree to the highest degree. So therefore it has to be constructed in a tight schedule, for which the steel structures was most opted. And as you know, when you go for steel structures, it is lightly damped, and therefore there are other issues that are going to come up with lightly damped and slender structures. That is, dynamic nature of the structure has to be understood. So aerodynamic performance of the deck need to be understood, because of the the design was done in such a way that to satisfy the aerodynamic requirements. So the dynamics is quite different. And if you see the dynamics of the wind, you can see there is a chimney next to the bridge site itself. You can see how the wind direction is changing constantly. So the wind speed is also quite high. And during the construction, the bridge, the cantilever, this was moving up and down. It was almost in 10 feet. So, and during the construction, it has the worst snowfall, and this was not anticipated even by the designers. So it had the worst loading onto the snow load onto the structure, and this was because of the monitoring. They were able to trace out, how much of stresses are getting into the structure. So the basically the Sapor Tempo OI, that is a future tech division that is in Finland, had the responsibility of putting the sensors in place and monitoring over a period of time since 2003. And so these are the various types of sensors. As you can see, the wind, environmental sensor, that is temperature, and the sensors are given most important. You can see where it is being incorporated. This complete picture is shown here, and this is the complete layout of the monitoring scheme that was provided, which I was involved in various other projects. This is an online monitoring scheme that is given to the user. As I said, it's the simplest fashion. The user can understand the experts or the people who take the decision makers can look into, and they can take a decision onto it. So there were various various web pages or the sub web pages that could be opened, and we can see what is happening with each of the sensors. So what are the findings of this being the very large structure? This is a long span structure. The temperature and humidity are very, very important, and you can see, as a matter of fact, the variation of temperature affects the vibration property of the long span bridges, such as these are very complicated, that you should be noting. And firstly, the temperature distribution and the variation in the temperature are generally non-uniform and time dependent, which includes the change of physical parameter along the different parts, and it is going to be completely asynchronous. So that's going to be. Secondly, all the members of the bridge change their size under different temperature, and the temperature, the contraction of each and every individual members are going to be different. The third is the Young's modulus and the shear modulus of the material, which are the main parameters determining the vibration parameters, are also going to fluctuate because of the complex nature and the complex system of the structural formation. The fourthly, daily and the seasonal variation in the temperature may change the stiffness of the bridge joints and supports, and thus strengthen or weaken this constraints, resulting in the apparent shift of the vibration properties, or sometimes we are not getting the true properties if in case you are just monitoring only the vibration properties, but temperature and the humidity played an important role. Lastly, the temperature variation results in the considerable thermal stresses or stresses redistribution structure, which change the vibration properties of the bridge. Now, as I said, we also this particular case study indicates that the temperature is critical source causing the variability of vibration properties of the long span bridge, and variation of model frequencies caused by temperatures in most cases exceeds the changes of frequency due to the structural damage or deterioration. So we also indicated this, and we saw that due to monitoring, we also found that there is no problematic action due to wind, and the fundamental frequency were within the order of what is being calculated, and did not because of the wind speed and other parameters, that is the real scenario, there was no resonance that was caused. So this was the finding of this particular project. And this SM technology, that is structural monitoring technology and system, have been to facilitate sustainable development through improvement of knowledge base, reliability, and safety in the design and assessment management for structural infrastructure. This particular data is being presently monitored by Russian Ministry of Emergency, and the data is being utilized by various academicians, and the people related to it, and they've been developing the knowledge base. So the few of the closing comment before I close this particular presentations. So basically, from this presentation, you should understand that structural monitoring technology is the inverse process of structural designs and verification, reflecting the variation of structural material parameters and geometrical characteristics, which is a change of structural response due to various environmental factors also. But the many field monitoring data indicate the structural response did not only relate to the characteristics of the structure, but also highly susceptible to environmental conditions. So you know that most of the monitoring cases, what we have seen, it is highly susceptible to monitoring environmental. So basically, you have the three cases in basic engineering. So the output analysis, input identification, and system identification, or the structural identification. Wherein in the structural identification, you have the unknown parameter to be the structure, and we know the input and the output. That means you know the input, what type of input that is going to come into the structure, and what type of output is going to come into the structure. If you have this, so defect in the structure will inevitably change change to its dynamic characteristics, and these changes may be detectable by dynamic loading and sensors. So whatever defect that happens into the structure can result in changes, and the dynamic characteristics can be detected by the structural health monitoring scheme. Obtaining accurate dynamic characteristics and to develop a accurate theoretical model to study the performance is perhaps the most challenging. And in this case, the structural health monitoring schemes helps. Now, basically, you take an input source, that is a free vibration, forced vibration, or ambient, and your structural system is completely equipped with structural monitoring scheme. You get the dynamic response, and because of the dynamic data analysis or big data analysis or dynamic data analytics, you see the you check out the what is happening with the data, and you try to extract the features or the you do the statistical assessment of these data and get the features of this particular trend that is happening because of the data. And therefore you try to develop a model. Basically it is called as system identification, which is a methodology for building a mathematical model based on the system dynamics using the measured data of inputs and outputs of a signal. So therefore you have the inputs and the outputs of a signal, and therefore you develop a model, and this particular process is called system identification. And since this is the identified system, which is closely related to the system that is on reality, therefore you get to understand the future performance of a structure if in case you use these updated models in your analysis. Now, this is a scenario that we are present day in, based on which is a base for the system identification of FIFI model updating. The future response of the system is studied for damage assessment and critical condition based on the data using SHM system. So you have a system in place. You have already updated the data in your software. That is, you have updated your model in your software using these data, and you have got the reliable FE model. You try to input the present day situation in real time and get back what is going to happen progressively. And you can also make a detailed study, and it encompasses various uncertainty. And basically, you'll have a more reliable understanding of the structure. Basically, in summary, it will have 3 stages of SHM. That is, you acquire the data from using the sensors and acquisition systems. And from this data, you develop a model or the dynamic model, and that's called the system identification. And it is by data extraction and feature extraction. And from the data, the model that is being developed, and you input the sensor data, and you also get the condition assessment, or you using the damage, the updated model, and as well as the inputting the realistic sensor data or the future data onto the model, you get the condition of the structure or the performance of the structure. So as you all know, the present day, the effect of the change in environmental condition or the dynamic actually is going to change the dynamic characteristics of the bridge. So basically, the temperature is the most challenging aspect of the present day research, and presently attracted most of the studies. If you just Google for this present day study on the temperature effect onto the various domains, you'll see most of the studies are done on the temperature effect as well as the change in climatic conditions. So therefore, the temperature plays a key role. And as you know that the structures are quite large, and the absorption of heat is going to be high. So it depends on various conditions. The heat exchange between the boundaries of the bridge and the environment itself is complex. It depends on solar radiation, convection, and thermal eradication. So although the solar radiation is one of the most important thing, and as you can see, it depends on various parameters, depends on the inclination and where it is, where the bridge is located, the orientation of the bridge, the solar declination, and so on and so forth. So you can look into these details on the thermal effects of structures, or to the thermal effects on civil infrastructures. There are various literatures on it, so therefore it will give you a fair idea. So presently, it has been one of the most attractive research among various engineers, researchers, and policymakers. Because most of the structures are more vulnerable to the climatic change, and climatic change is a big hot topic of this day. So definitely you would understand that that you need to monitor most of the structure. And this is a scenario that this is the scenario in USA presently, because the data are available. I just had to fit. So the vulnerability of the structure to climatic change is quite an important topic, and this has attracted most of the researchers. Now, today we are in a state wherein we are not just monitoring only the data of importance, but we are also monitoring the data and as well as the other condition that affects these. And this particular technology, that is the temperature-based system identification and temperature-based structural health monitoring process, or the structural temperature-based structural monitoring, is presently being accepted and is being practiced. But all this while we are doing it without looking into those fact checks. But presently it is already well developed, and there are a lot of algorithms that is already developed, and people are looking into these data. From the temperature-based system identification and the temperature-based structural monitoring, the measured values are just the temperatures, temperature gradients, strains, and displacement, nonlinear and linear and nonlinear analysis of the measured inputs and the responses based on the characteristics of the observed value and the final target of this structure identification. So prior to the finite element updating. So basically what you do is you monitor all the parameters of temperature, environment, and the temperature gradient, stress and displacement, non-linearities and linearities, and you observe the trend, and then basically you try to develop a system or the model of the system using these temperature or the environmental condition based inputs. So basically, it is already in books and it's already in literatures, and it is already up into various studies in well-developed countries, and as well as where people are extensively using structural monitoring. So you can see that there are two approaches, that is to consider the temperature, and not the next one is to not to consider the temperature. But both of this has its own, if you consider temperature, that would give the most realistic behavior of a structure, because it gives you a complete fair idea. And there are few studies that are done by taking away the temperature also. So this itself is a big study. I've just given you information that the temperature removed response is quite different, and the temperature induced response is quite different. And you can see what happens with it, and including the temperature gives you the most realistic response of the system. So presently, this is the present day scheme that has been extensively used. As I said, I emphasized on the environmental temperature and relative humidity. This is the input that is also taken care by the structural system. And then you got various type of responses, and you acquire the data, you identify the signature. Using the temperature based or the environmental condition based system identification, you can develop the proper model of it. And then by you continuously monitoring further, you can see the long-term performance of the structure, and therefore you can come to some conclusion. This is the important, this is the present day trend that is happening, and that is real. That everybody is going with the temperature based structure identification and temperature based structure monitoring scheme. So in conclusion, the data and information obtained from structural monitoring scheme offers several contributions. That includes the result can be used to evaluate the safety and serviceability of bridge by comparing with the design criteria. The results can be regarded as the set of reference data serving to eliminate the effect of environmental parameter in evaluating the condition of a bridge. As we all know, for example, in assessing the effect of the traffic load, the temperature effect should be removed from the original measurement. The quantitative effects of the environmental parameter on structural response can be employed as a damage indicator. If in case you can see that the expansion joints or the abutment is completely or partially restrained for longitudinal movement, the measured displacement will show different parameters, so that we know very well. So I thank you all for your patient hearing. It was quite a vast topic that I had to, and since this was a COVID situation, I took an opportunity to put all the information that I had gathered over a period of time with my experience, and as well as with a lot of reading and looking at the present day article of the present day, the traffic that is being closed on I-40 bridge. So had to put in place and put it in such a way that it's quite understandable by most of you during this online presentations. I hope that my presentation was quite reachable to everyone, and it was quite understandable. I thank you one and all for your patience hearing. I would do so. Just a minute. Can I unmute all? I need to unmute. Yes, I'll do that.
I have done. Okay. Okay. No issue, sir.
Yeah.
Yeah. Okay. Uh,
Professor Sanath?
Yeah, yes, sir. We are audible, sir.
yes, sir.
We are really blessed and honored with your presentation, sir. Excellent presentation, and you are given totality of the structural monitoring. You are a dictionary for structural health monitoring. All our webinar delegates are very attentive, 50 plus all professionals. Even the quality of presentation, what you shared is extraordinary. Almost you have taken 2 hours, 20 minutes. Your energy levels are unbelievable. Even I'm very today I enjoyed your lecture, the content you have given, the quality of slides you prepared, and really you are educated all of us by giving this type of inspiring lecture on structural monitoring. I believe that all delegates will agree my words. We are really honored with your presentation. Thank you very much, sir. Thank you a lot for your time spending with us, and the way you prepared, unbelievable, sir. Actually, you have given the basic information, background informations, you are given all the required of the structural health monitoring, and also what are the various instrumentation to data monitoring, data acquisition, how to do the analysis. See, analysis and inference is a very, very important in case of structural monitoring, very true. And also I have only one question for you, sir, if time permits.
Definitely, sir. I'll be happy to take. Anyway, it's a code
So
situation.
you
So
presented all the types of the sensors used for structural monitoring, and you mentioned some sensors will be inbuilt in the structure, some sensor can be put outside as a surface. If you see the life of the sensors, what is the approximate life of sensors, whether the life of sensors will more if it is embedded or surface, this is one question. The second question is, what is the approximate cost of the total project can escalate if you go for this monitoring system for the new projects?
okay, so I would reframe your sentence, this question. First is that what is the life of a sensor? The next is what is the cost of the project, or what is the cost of the structural health monitoring projects? And what will be
if
the
I want to
approximate?
introduce that monitoring system, what is the percentage increase in cost?
Right.
Project cost.
So, yeah, the first is the choice of the sensor dictates the cost of the sensor. Now, the choice of the sensor is again, based on your understanding on the material behavior. Let's say the material is undergoing much of fatigue, or there is much of fatigue load onto the structure. Therefore, your data recording has to be done over a period of time, which will also take care of the fatigue. The electronics, the people who sell sensors, or who are going to, where the organization who are involved with sensor technology, would define the life of a sensor based on the fatigue life or the fatigue cycles. So basically, you from the civil engineering point of view, as I've been only a civil engineer, so I look at the times, the temperature at which the sensor would survive. So if in case, what is the life of the sensor? If you're asking, I think I'm looking from the civil engineering point of view, is that when I embed within the structure, when it is concreted, will my sensor be performing better, or will be performing as said, is your question. That's what I understand. So if that is the case, you have to look into how you protect your sensors and how you place your sensors. And that will define how well it is going to perform. And it will also define how many days it will perform, or how many years it will perform. And how long it will perform from the electronic point of view is that every of the electronic gadgets has its own lifespan, and that is dictated by its reliability, and it is dictated by its fatigue life or the fatigue cycles. So basically, if you go for, if as an engineer or a not learned electronic guys, what we ask from the sensor individuals or people who are involved with sensors is that we would just tell them the scenario that we have a bridge, and that bridge needs to be monitored for so many years, and this needs to be monitored at this situation. The climatic condition is going to be that, the operating temperature is going to be this point to this point, the minus and the plus will be given, and the number of cycles that you can expect, whether it is going to be monitored dynamic or static, whether you want to monitor every second or fraction of a second, or you want to monitor per day. So when you say this individual inputs, the sensor experts would choose or make a choice of the sensor that will be working for that particular situation or a particular specific case. But again, you try to implement it, and the reliability of the sensor is always there because it's CE certified. So therefore, it is 1 in million that may fail sometimes because of lack of because of its manufacturing defect. But when it comes to the placement, takes a major role on the life of the sensors. So most of the sensors that has failed is improper understanding of the sensor and its application, and the improper choice of the sensor. That is, I myself made a wrong choice in the initial days. That is for the first project in the first day. I would say that way. So first day I made a wrong choice, and the second day I got it corrected. But that's the first mistake. That the more mistakes we do, learn from it. And sometimes more of the time we embed wired sensors into the concrete, wherein we don't understand the mass concreting properly and the temperature that gets into the concrete. Therefore, this also leads to the failure and loss of life of that particular sensor from the civil engineering point of view. Hope that will answer. The next thing is that the cost. Again, as I said, the basic cost, I have worked with large projects, and as I can say, compared to a project, if in case I would just tell you one of the projects which worth about 1,200 crores, okay, and the cost of this particular sensor technology was 8 crores only.
Okay, sir. Okay.
So if you can take a, okay, so now if you are looking specifically at a bridge project, if it goes about to 100 crores, and the cost of the sensors were only 5 crores. So you can make
5% of the escalation.
Yeah, it is less than that. Basically, what I've seen is because the other service charges is the more than the sensor cost or the instrumentation cost is the service cost. Yeah. And the further part after instrumentation, after the initiation of the project, the other the cost that is going to come because of this is going to be huge rather than the instrumentation. So the instrumentation is going to be basic cost only, and you can say, I mean, roughly you can say per sensor 2 lakhs.
Okay, sir. So hats off to you, sir. Really, unbelievable. It is the first time I am attending a webinar of 2.5 hours. With a lot of information you have shared. I'm very much thankful to you, sir. Even webinar delegates are really enjoyed. I'm seeing all these things. If any questions from the delegates, otherwise the coordinator, I request.
One question is there, sir.
Propose
One
the vote
question
of
is there.
Yeah. You
one
take a
question is there from the YouTuber. Can this system will be applicable for underwater structures? Okay,
so the situation with underwater structure is that if in case it's a corrosive area, underwater instrumentation is done extensively. You can see that the water levels in sea level is also monitored regularly in the global basis, and the monitoring again, we can use various technologies for this. Underwater schemes like the wells, the bridge foundation that goes deep, the well foundation is also monitored, and the surface of those are monitored, and the offshore structures are monitored, that is in highly corrosive zones. So there are various technologies that are presently being implemented. Yes, underwater can be monitored, but there are, again, every of the has its own limitation. I can only discuss if in case you have a specific problem. So the general answers to that is you can monitor anything and everything. Yes, there are limitations. There will be conditions wherein you need to pack up things like, you may have a highly corrosive zone. So you may have to have some remedial action for it. And then you go with your monitoring scheme. But when you go with the remedial action, that could hamper your monitoring scheme also. So therefore, you may have to have a, you have to take a decision on that because of the trade-offs. Yes.
Any questions from the participants? Sir, some of the participants asking for the present PPT, sir,
Okay,
slides.
most of the time this has been the question, but I will definitely try to do something on this because few of the data are of my the previous companies which I have only used for education purpose. So I can share a few of the things, but I've uploaded most of my materials on YouTube.
Oh, thank you very much,
Okay.
sir. Thank you a lot, sir.
I hope
Okay.
this presentation is also going to be on YouTube because it's already live
Yes,
telecast.
sir. Yes, sir. Yes, sir.
Why, sir?
Yes,
No
sir.
need of fear. YouTube, it is there.
Yeah,
Anybody can go that.
yeah.
Yeah.
If there is
Thank you.
any specifics, anybody requires any consultancy or any type of understanding on this and doing the research can always hop into my department. I'm at the PS University in the Department of Civil Engineering. Anytime you can walk into my chamber and we can have a discussion. There are a few people who met me earlier who wants to do their higher studies on this. Definitely you're welcome. I'm open to any type of discussions or any type of collaborations.
Thank you very much thank you very much, Professor, for this open invitation. I think now the webinar delegates and who are all interested make use of that. Thank you once again, and I request the coordinator, Mr. Sanat Kumar, and also thank him for coordinating this webinar. And now I request him to propose the vote of thanks.
Thank you, sir. Chandramouli, sir, you have taken a lot of time in explaining the each and every concept. We are very thankful to you. Totally, you have taken 2 hours 35 minutes till now, and I appreciate your energy level. So you have from 2.5 hours sitting in front of the computer or laptop. It is a very difficult task. I would like to thank, and even you are patiently answered the question after this, and we are really.
Sir, can I interrupt it here? Sorry for it.
Yes, yes, sir.
I would give an information on this particular webinar. I've been situations wherein in the previous days, we had a situation where people won't understand what is SHM.
Okay.
The second thing is that we had people who know SHM, but not to the fullest extent. So I've been called for various presentations to give talk, but I've seen people giving a summary of their findings, but which is not educated. So I feel that the webinars and whatever is created from the department, since now I'm a professor, now I'm not into the business line, the best way is to educate people the way, and the only way of understanding things, because people don't ask and people don't disclose, the only way is to express whatever you have. And during the COVID situation, the number of death and the number of people that expertise who are my friends whom I lost is, there are people who had a lot of knowledge. There are a lot of knowledge and they couldn't share it because of various reasons, because they were not reachable and they had no people and a lot of other issues. Now the only way to develop this nation or develop this globe and to leave your print, as you have the carbon footprint, you have to leave your print by giving the knowledge out. And once you create a knowledge base, I think there is going to be a competition and development. I think this webinar, although I know that there is not going to be any constraint on my explanation, most of the presentations whom I'm called on, I don't understand. I mean, I don't even debate on my time because I give more time to it. But the whole idea of any presentation conference or any talk is going to be just a share of knowledge and developing. I'm on to the other side of developing the knowledge base. I therefore wanted to make this presentation. In fact, I would tell you that once you gave me an invitation, I started making this presentation, the flow of thoughts, because I understood that temperature and humidity is a present day trend. This is the best time to educate people on temperature and humidity because they know the seriousness of things and I can put things in context. So therefore, the presentation, although I had to put it long, the idea was to give all the knowledge what I have so that I have a better better competition, so that the business grows, as well as people are in COVID situation. They also want informations, and I want to leave my footprint because most of them, they didn't have an opportunity to leave before they left for the better world. So thank you, Sanat, for the patience. I'm sorry I interpreted and carry on. Sorry. Thank you.
Okay, sir. Okay, it's okay, sir. Now I would like to thank on behalf of our Department of Civil Engineering, on behalf of HOD and management for your wonderful presentation. And we will be in touch with you, sir. And at the same time, I would like to thank my HOD for giving me an opportunity to conduct this webinar. on this day. And his continuous support, continuous encouragement, which has made me to reach out to many people. We have received around 250 participants, and we have communicated all of them, and most of them joined with the YouTube, and most of them joined with this Zoom meet also. And I really thank them also for giving their time and gaining the knowledge from you, sir. And I'm thankful to all who are supported directly or indirectly for the successful of this webinar. Thank you, one and all, sir. We can conclude, sir.
Yeah, thank you, Professor. Once again, your words are very truly honored, and you have justified the webinar content. The way you presented, shared, definitely we'll all join hands and fulfill your dreams. Definitely, we will have once again in future on some of the few webinars under your guidance. Thank you once again for you and your institute for presenting today. We really enjoyed, and it is one of the memorable webinar in my life. Thank you, Professor. Thank you all delegates for supporting us for conducting such a interesting webinar on the new topic, upcoming topic. Thank you once again to all of you. Please fill the feedbacks for certificates. Sanat, you have taken the sir signature for certificate?
Yes, sir. Yes, sir. Yes, sir.
Okay. Thank you all once again.